Okay, so we're going to move into rational roots, very much related to what we saw in the previous section. And so that now we can have fractions in our powers. And so as a general definition, if I have something to the 1 over n power, that's the same thing as taking the nth root of that number. And so if we have a number and we say 8 to the 1/3, well, it's good to translate that, put that as cube root of 8, which is 2. We've seen that in the previous lecture. And that's generally the right idea when we are dealing with evaluating. We're trying to simplify something down, and it's kind of hard to think about fractions as powers. We just translate it. So we translate this. I think I broke it up into 2 pieces, but you could have just translated it into a single cube root. And so that will make it so that I take the cube root of -27 and then the cube root of z to the 9th, z to the 3rd. Just take the cube root of -27 to get -3. So my final answer is -3z to the 3rd. Now, more generally, if I have m over n, then that kind of can be translated 2 ways. I can say that I'm taking the nth root of something and then taking it to a power, or I'm saying I'm taking something to a power and then taking the nth root. We typically do the first form because that makes it so we're dealing with smaller numbers and then taking the power versus the other direction, but they're technically equivalent. So if I'm doing 8 to the 4/3, I take the cube root of 8, which is 2, and then I take that to the 4th power, and then I get 16. And so we do have to be careful, just as a heads up, I'm not sure we see this in any examples, that if once we take that power, or once we try to take the root, if that's a negative root, we can't really deal with it. Where if I have some sort of even power and an even root situation, then I can actually take the square root of that or the even root of that, because once I take the power of that thing, it would turn it positive, and then take the square root or whatever root of it. If that doesn't make sense, ask me about that in class. I don't think we'll actually see it in any examples or on any exams though. So again, here I have this kind of fraction that seems weird to take something to the 5/2 power. So I'm going to take the root of that entire fraction, and then I'm going to take that to the 5th power. And then I can apply that 5th power into each part. So, well, the square root of 9 is 3, the square root of 16 is 4, so that gets me to the 3/4 to the 5th. And now I distribute that power to the top and the bottom, and I get 3 to the 5th over 4 to the 5th, and I guess I get that equal again, which is technically true. And then 3 to the 5th is 243, 4 to the 5th is 1024. No, I don't have those answers memorized. I just would throw that into my calculator. 5th powers are a little bit tricky. Now, if we have negative exponents, and this is true even outside of the fact that we're dealing with fractions in our powers, I take whatever that thing is, I move it to the bottom of a fraction, and then I change the power positive. Now, if it's already on the bottom, am I going to say this? I'm not. If it's already on the bottom of the fraction and I have a negative power, I move it to the top of the fraction and change it positive. So it can work both ways. And so to kind of resolve this question, 8 to the -4/3, I move the 8 to the bottom of a fraction, and so I would have on the bottom of my fraction 1 over 8 to the 4/3, and then I'm going to translate it. So I kind of did that in one step. So the cube root of 8 is 2, and 2 to the 4th is 16, so I get 1 over 16. Now this is kind of a quick table. I would recommend pausing here if you want to get them all the notes, all of these down in your notes. I'm probably not going to read through all of them. I'm going to highlight the ones that we're going to see the most is probably that produce rule. That's the product rule. So when you're multiplying two things and they have the same base, and they have to have the same base, you will add the powers. And then similarly with the quotient rule, when we're dividing, we subtract the powers. And then we talked about negative exponents, we're talking about rational exponents. Anything to the 0 power is 1. That is super helpful and nice, especially if you have something really difficult to deal with as your base of your exponent. By the way, I don't know if I've mentioned it, the base is the thing that we take the power to. The power is, well, it's power. So if I have a to the m, my base is a, my power is m. Okay, so anything to the 0 power is 1. And the other things I feel like are so intuitive that you're probably going to start using them fluently without really thinking about memorizing them or anything like that. So with that in mind, here we have 2 powers. We are multiplying them. Both of the bases are x, which is good. And now I just go ahead and add my powers. So 3/5 plus 1/4 gets me, I think I do a little bit of fraction magic over there, getting a common denominator, but it ends up being 17/2. So that's one of the super important rules of exponents, that if you're multiplying them, they have the same base, then you add the powers. This example I'm not crazy about. It's kind of hard to track because it is factoring, but it's factoring involving fractions, which is kind of scary. And so I imagine I'm going through this because there's probably a MyMathLab question, but I don't think this is going to be on any exam. And if it is, I'll just make it kind of a bonus question. All of that being said, it's certainly doable. So if I'm trying to solve this equation, I can actually solve it by factoring, because even though it doesn't seem that way, x to the 1/3 actually fits into both of my terms. So I'm going to factor out that x to the 1/3, divide both of my terms by x to the 1/3. Here I do a little bit of fraction magic again, 5/6 minus 1/3. I get a common denominator, and so 5 minus 2 is 3/6, which simplifies to 1/2. And so I can simplify my equation down to x to the 1/3 times 2x to the 1/2 minus 1, and set that equal to 0. And then I solve each of the pieces. So I set x to the 1/3 equal to 0, and then 2x to the 1/2 minus 1 to the 0. I guess I solved my equation first. In order to undo a radical, that was 1/3 is the cube root of x. So I would have to cube both sides, and well, 0 cubed is 0. And on the other one, I would move the 1 over. I would divide both sides by 2, and then x to the 1/2 is the square root of x. So I would square both sides, and I would get 1/4. 1/2 times 1/2 is 1/4. Like I said, this one's it's tricky, and that seeing that the fact that the x to the 1/3 factors out is honestly probably conceptually the most difficult part of this question, but there's just so many places to make mistakes here that I think this one's a little bit higher of a difficulty than something you would expect you guys to do on an exam.